Assalamualaikum. Today we're going to learn about data structure. In this chapter, you're going to learn about single structures, array of structures, structures as function arguments, dynamic structure allocation, unions, and some common programming errors. This lecture will be divided into a few parts. We're going to start with part 1. I'm going to introduce you what is a structure. Structure basically maintains a record of items in inventory, and for example, it has few information about each inventory, such as part number, description, quantity of stock, and price. Each data item is a separate entity referred to a data field. Taken together, it will become a record, which in C++ it is called a structure. Therefore, in here, we are going to learn on how to create, fill, and manipulate structure. Data structure or a structure is basically it stores different type of data under a single name. A structure is a class that has no method, and to create, you have basically has two steps. The first step is declaration, and the second one is assigning its value. To declare, basically, you have some syntax that you have to follow. You have to list the data types, data names, and arrangement of the data items. For example, you're talking about a birth structure, which consists of 3 data items, and it fields called structure members. So it begins with a struct, and you have 3 data types. The first one is integer month, and you end with a semicolon, and you have integer day, and it ends with a semicolon. Another one is integer year, and it's end with a semicolon. And the name, basically, you can put it at the end. In here, it is called the birth structure, and again, after the name, you put a semicolon. Next, after you have basically declare the members of the structure, you started to assign data values to data items of the structure. This particular exercise is called populating the structure. Right. Data structure members are accessed by giving the structure name an individual data type separated by a period. Period is called member access operator or the dot operator. You can refer to program 16.1, which tells you on how to assign values to individual members of the birth structure. This is a program that defines and populates structure. First, we have a structure with 3 members, which is integer month, integer day, integer year, and the structure name is a birth. Therefore, this is called a birth structure. For populating the structure or assigning data values to the data items of the structure, first we have the dot operator. For example, birth.month is equal to 12, referring to the month. Birth.day is equal to 28, and birth.year is equal to 1992. To print out the structure, basically you can use the cout. For example, cout, my birth date is birth.month, which will call out 12, birth.day, which will call out 28, birth.year, that will print out 1992. The output basically is my birth date is 12/28/1992. And you can have format of the structure, which is very flexible. You can have something like this, right? In a single line, structure, integer month, integer day, semicolon, integer year, semicolon. You have to remember that you have all the semicolon after each of the member of the structure. And of course, you put a name towards the end, which is birth, and again, you have to end with a semicolon. You can also have a multiple variables which are declaring the same statement. For example, you have 2 structures. The first one is the birth structure, And the second one is the current structure, which actually have the same members. The first member for both structure is integer month, the second member is integer day, and the third one is integer year. Therefore, in creating the structures of the same form, you have birth day, birth month, birth year, and you can use it for the current day, current month, and current year. So basically, other than that, you can also declare it something like this. You have structure and a name goes on top of it, structure date, and you have all the members in here separated with semicolons. And towards the end of the structure, you have to end with a semicolon. Right? In this particular program, you can see that you have structure date with 3 members, right? And then you have another integer main, which you populate or you initialize all the value. For example, you have date, birth, meaning that birth is basically using the structure date, which refers to the global declaration. Then you have the month, birth.month is equal to 12, birth.day equal to 28, and birth.year is equal to 1992. The cout of this program will be exactly the same with the previous cout, which my birth date is 12, 28, and 1992. Right. Initialization of a structure follows the same rules as initialization of arrays. For example, you have date, birth is equal to 12, 28, 1992. So this one can replace your first 4 statements in the main program, and all the main members are separated with a comma. Therefore, this one is basically replacing the 4 statement previously, right? You can see that it initializes or populates its value by putting in an array. Therefore, the 12 will belong to the month, 28 will belong to the day, and 1992 basically belongs to the year. When you see out the program, it will be exactly the same with the previous cout. Next, we are looking into arrays of structures. Real power of structure is realized when same structure is used for list of data. For example, here, you have processed employee data in figure 16.1 of your text. You have a few options. For example, this is data basically. You have a list of employee data. The first column is basically talking about the employee number. The second column basically talking about or displaying employee name. And finally, the third column is the employee period. So how we are going to basically design or identify or write the following syntax and structure. You have a few options. The first one, consider each column as a separate list stored in its own array. So you have, for example, employee numbers are stored in an array of integers. Names are stored in an array of strings. Period is stored in an array of double precision numbers. And what will happen? Alright, you are basically putting the whole thing as an array. And then you have employee name as an array. And you have your employee period as an array. You also then have option number 1 is not a good choice because you cannot see the relationship between all the elements of the column. Because when you're talking about this kind of data, you wanted to see the relationship between each of the rows rather than looking into a column wise. Then you have to use a structure which is shown in figure 16.2 where you can process it as a single array of 10 structures. Therefore, it will maintain integrity and data organization as a record. So you can see that the first structure is basically containing the first employee name, employee number, employee name, and its employee period. Therefore, in total, you have a 10 structure which basically maintain the integrity and all the relationship between each of the column can be seen and can be extracted. Right. Declaring an array of structure basically is the same as declaring an array of any other variable types. If data type pay record is declared, for example, you have struct pay record, you have 3 members, ID name, num, string name, and double rate. Therefore, you can then define array of 10 such structures by putting numbers toward the ends of the structure name. For example, you have pay record, you have employee, which will referring to all the structure of pay record, and you have 10, and you end with a semicolon. This is the example. You have include IOStream and all the libraries, and you have a global declaration, structure pay record, integer ID, string name, double rate, and we end all with the semicolons. And then you have 5 records basically, and when you are initializing or populating the values, you have pay record, which is a structure name, and then you have the member of the structure with this employee, and the number of records is 5. And then you put all the values in a parenthesis, and you separate them with a comma, and towards the end you end with a semicolon. And then to print out all, you have to use a for loop, right? And then you make sure that it goes to each of the members, ID, name, and rate. Right? So basically you can refer to each of the member by putting the value or giving the array number. Exactly the same when you are using an array. For example, it begins with index 0, which is basically the element number 1. This is the end of part 1, and we're going to continue with part 2, where we're going to talk more about using structure as a pointer, and then we're going to discuss about union.